Before construction could begin, engineers first had to turn an architectural idea into something buildable on a steep mountain slope. The terrain dictated almost everything. The bridge had to follow the mountain rather than force a straight route across it. Support locations were studied along the curve, balancing the pedestrian route against difficult access and changing ground elevations. The giant hands were architectural features, but they also had to fit precisely around the bridge's established geometry. At roughly 5 meters wide, this was a pedestrian structure, not a roadway, and every construction operation had to respect that scale. Once the concept was workable, the job moved out of the studio and onto the mountain. Before excavation, survey crews carried their instruments into the forest to establish the bridge's position on the real terrain. A total station allowed the team to transfer the designed alignment from drawings into precise points on the mountainside. The prism moved from station to station, gradually tracing the future pedestrian curve through dense vegetation. Small corrections here mattered later. A misplaced support would disturb the geometry of every steel segment above it. Each confirmed point became a physical reference for the foundation work that would follow. With the alignment established, the survey crew handed the mountain over to the construction teams. The first challenge was not the bridge itself. It was creating enough controlled access to bring people and materials into the site. Ready-mixed concrete had to travel up the mountain instead of relying on a large, conventional batching operation beside the foundations. Tight turns and steep access meant the trucks had to move slowly, often under the direction of ground crews. On this approach, every load of concrete had to reach the work zone before the real structural construction could begin. At the site, the truck was positioned carefully so its delivery path could reach a relatively small foundation area. The process had to repeat without turning the narrow mountain access into a permanent industrial road. With equipment positioned and the foundation points marked, excavation could finally start. Excavation began only where each foundation was required, keeping the disturbance localized within the forested slope. After reaching the working level, crews cleaned and prepared the base for reinforcement and formwork. Steel reinforcement created the internal framework of each compact reinforced concrete foundation. Formwork then defined the concrete shape, while keeping the reinforcement in its required position. Fresh concrete was placed around the reinforcement, while vibrators consolidated the mix and removed trapped air. Once placement neared completion, the upper surface was consolidated and finished before curing began. Removing the formwork revealed the permanent concrete base that would receive the steel support above. The same sequence advanced along the curve, leaving a chain of foundations at different stages of completion. The next permanent elements were slender steel support members, far lighter in appearance than conventional highway bridge piers. Before lifting, crews checked the interface between each completed concrete foundation and its future steel support. The crane took the load, lifting the steel member clear and slowly rotating it toward the vertical. The support was lowered toward its foundation, under controlled crane tension, while crews stayed outside the pinch zone. Survey checks and small crane corrections brought the member into its final vertical alignment. Smaller branching elements near the top created the geometry needed, to receive the curved walkway above. One by one, the steel supports began to define the future path of the bridge across the mountain. But before the walkway could be lifted, crews needed safe temporary access around those elevated connection points. Localized scaffold systems were assembled around the supports, creating temporary working levels without covering the entire mountainside. Upper platforms gave crews a secured place to work close to the future steel segment connections. At this height, worker safety depended on stable platforms, full-body harnesses, lanyards, and reliable anchor points. These temporary access points progressed support by support, following the same curved route as the future walkway. Once the receiving platforms were ready, the crane was repositioned for the first major superstructure lift. Nearby, a raw curved steel walkway segment waited on staging for its turn in the air. Before each lift, crews inspected the raw steel segment, its orientation, and the locations used for rigging. The crane first took tension slowly, allowing the crew to verify that the load was balanced before leaving the staging supports. The moment the segment cleared the cribbing, every movement depended on the crane, rigging, and tagline control. Suspended over the slope, the segment was moved slowly toward the next support, while crews controlled rotation from safe positions. As the structural gap narrowed, large movements became tiny corrections, measured in alignment rather than speed. The segment was temporarily secured, while the crane continued carrying most of the suspended load. Only after initial securing could crane tension be reduced, and the new segment begin transferring load into the structure. That lifting cycle repeated farther along the route, extending the raw steel frame one section at a time. Eventually, the separate lifts became one continuous curved structural walkway across the supports. With the main steel frame continuous, crews could begin turning it into a usable pedestrian walkway. Secondary supports and the first walking surface sections began covering the previously open structural frame. Timber elements then formed the pedestrian surface, installed progressively rather than appearing across the bridge at once. At one point, the same bridge could be read in 3 stages: exposed steel, active construction, and finished walkway. As the timber surface advanced, the remaining gaps between completed sections grew smaller. Slender gold-toned railings were added along the edges, giving the bridge its recognizable architectural character. By now, the Golden Bridge was visually recognizable, but its most famous elements still did not exist. The walkway was nearly complete. The mountain was still waiting for the 2 enormous hands. Construction now shifted to separate work zones beside the bridge, where the giant hands would be built around internal steel frames. Long skeletal members established the direction and proportions of the future fingers. Transversals then gave each finger volume, taper, and curvature, rather than leaving it as a simple steel tube. As more fingers rose, the outline of a human hand slowly became visible through the open framework. Beside the giant finger frame, a single worker makes the true scale of the sculpture immediately clear. The first hand eventually reached a complete skeletal silhouette, with palm, fingers, and thumb connected as one form. At another point along the bridge, Crews repeated the process for the second hand in a different orientation. Both hands now existed, but they were still transparent steel skeletons, not massive blocks of stone. Metal mesh was attached over the ribs, creating a continuous surface while still revealing the steel skeleton beneath. Here the construction layers can be seen together: exposed mesh, raw fiberglass, and the final weathered finish. As mesh coverage increased, the open frame began to take on the full volume of a giant human hand. Fiberglass was then formed over the mesh, producing the opaque outer shape without turning the hand into solid stone. The outer form advanced along each finger, while uncovered mesh remained visible farther ahead. Eventually, only small areas of the underlying mesh remained exposed beneath the nearly complete raw shell. Final surface treatment changed the pale raw shell into the aged, stone-like appearance seen on the finished landmark. With both hands finished, the illusion was complete. Monumental weathered forms surrounding a lightweight pedestrian bridge. The remaining scaffold could now come down piece by piece, exposing the completed architectural forms. Planting strips along the walkway added the final landscape layer between the architecture and the mountain environment. At this stage, construction was no longer about heavy lifting. It was about small details that visitors would eventually see up close. Engineers made final checks along the timber deck and railings before the structure could be handed over. With temporary works gone, the completed bridge was finally ready for its last engineering review. The final walkthrough brought the project back to the same route that had existed only as survey points months earlier. The giant hands received their own final visual check, including the deliberately aged architectural finish. Once the engineers left, the construction site effectively disappeared from the bridge itself. At roughly 1,414 meters above sea level, the completed Golden Bridge now followed the mountain exactly as the original alignment intended. What began as survey marks, concrete foundations, and raw steel had become one of Vietnam's most instantly recognizable architectural landmarks.